have to see how electromagnetic wave structure is, or how electromagnetic wave is present. Already we discussed electron is vibrating in the atom, right? So here, due to electron vibration, first we can able to get a electric field like this. Whatever the vertical lines are there, so that particular structure here we consider as electric field. Electric field is expressed with E, right? So this indicates direction. So electric field direction is like this. Means it is best example for electric field nature is transverse wave, right? Then when electric field is created, then you can able to create the magnetic field. Magnetic field here we call as B, right? So that magnetic field direction is able to express it with shown with parallel lines. So here we clearly written E stands for electric field and B stands for here magnetic field. These two are perpendicular, means if one is an x-axis, another one is an y-axis. Then this one able to move on x-axis, right? And this one is in y-axis like this. So one is in x-axis, another one is in y-axis. Means two are perpendicular. Even though two are associated, right, along the one direction, right, this particular direction is indicates the direction of light. So the direction of light is associating of two fields. One is electric field, another one is magnetic field, right? So as a result, the light wave is electromagnetic wave, right? Understood? Discussing about electromagnetic wave structure. So already electromagnetic wave structure is in transverse wave. Already we discussed in that we have two different waves. One is electric wave, another one is magnetic wave. Two are associated in perpendicular, and that is called light ray path. Already we discussed. Then every light ray is having energy. That energy is identified, or that energy is calculated or depends on two factors. One is wavelength, another one is frequency. So how to know what is wavelength and what is frequency? That already we have a previous knowledge. Here, if you take this particular electric field is in particular transverse field nature. So this is the first point at the highest peak. Then this is one more one that is at highest peak. Then whatever the distance is there between these two peaks, that we call the wavelength. That we call as wavelength. So that wavelength we simply express it with lambda. Already we written on the particular gap of these two peaks. Then we have a discussion that is about frequency. So frequency means the number of waves which are able to cross at a particular point in a unit time, that we call the frequency. For example, already we discussed in a stable water, if you drop the stone, right, exactly in the end of that particular water resource, we can able to see the number of waves are able to reach. It is possible to count. So the number of waves is crossing in a particular point in a unit time, that we call the frequency. So these two are able to characterize the light energy. Understood? Speed of light is 3 into 10 power 8 meter per second in vacuum and in the air. Both values are same. And in simply we can able to express in the formula speed of light C is equal to nu into lambda. Means frequency and wavelength product value is equals to speed of light. Then if you take particular electromagnetic wave, so it is having both values are different, because all light waves not having same value of wavelength and frequency. Means frequency and wavelength is changed light to light. Means we have different color of lights, right? So when you take a particular light wave or electromagnetic wave, it is having different values. So whatever the different variated frequencies or different variated wavelength lights are there, that entire range, means from starting to ending values the total light waves that we call as entire range of frequencies or entire wavelength of electromagnetic wave we call as electromagnetic spectrum. Electromagnetic spectrum. So in the electromagnetic spectrum we have 7 type of waves. So we have shortest wavelength to highest wavelength, right? So if wavelength is 0.00001 nanometers to 0.01 nanometers, the shortest wavelength is for gamma rays, gamma. Then, if the wavelength is 0.01 nanometers to 10 nanometers, that is X-rays, X-rays, what we are using in scanning. Then one more, if wavelength is 10 nanometers to 380 nanometers or 400 nanometers, that we call UV, ultraviolet. Then one more, 400 nanometers to 700 nanometers, that we call as visible spectrum, what we are seeing from different colors, from violet to red color. Then, if wavelength is 700 nanometers to 0.3 millimeters, that we call IR, infrared. Then, if wavelength is 0.0 millimeters to 10 centimeters, that is for microwaves. Then last one, 10 centimeters wavelength to 1 kilometer wavelength, that we call radio waves. Means when wavelength is changed, we have different waves or not. So this entire range of rays or entire range of wavelengths or frequencies we call as electromagnetic spectrum. Electromagnetic spectrum. So it is started from gamma rays and ends with the radio. Means this is the shortest wavelength and this is highest wavelength. Moreover, here frequency is more, here frequency is less. Moreover, last but not least, we are having all type of waves uses, especially when we are able to talk in the mobiles, we can able to get radiation. So that radiation character is for gamma rays. Means they are very short one. They are able to give more energy because frequency is always able to show energy. Means if frequency is more, ultimately the energy also more. Means in the entire type of waves, the highest energy for gamma rays, the lowest energy for radio waves. Understood, children? What a clarity?